Hi GOR, this is Unit 3B and we're doing Lesson 4 today, which is on rectangles. So you guys all know what a rectangle looks like. Basically a rectangle has 4 sides. It is a quadrilateral. It's also a parallelogram and it has 4 right angles. So just make sure that you understand that a rectangle is a parallelogram, because to be a parallelogram, all you need is opposite sides parallel, and a rectangle obviously has that. So all the properties that we learned about parallelograms yesterday are true for rectangles also. They have opposite sides congruent, they have opposite sides parallel, they have opposite angles congruent, the consecutive angles are supplementary, and the diagonals bisect each other. Plus, the rectangle has 2 other properties. The first one is important. The diagonals are congruent. That is a frequent question on the Regents. So a rectangle has congruent diagonals. If I was to draw the diagonals right here, I'm just going to pick a different color so they pop out. You can see they look like they're the same length. Okay, so the diagonals are congruent, and the other one you already knew about is that it has all right angles. All right, so let's do some problems, and again, we're going to try a proof together. So question 1, I want to find QR. Remember, opposite sides are congruent, just like in a parallelogram, so QR is going to be 10. I want to then find SR. The bottom is whatever the top is 24, so the bottom is 24. I want to find SQ. Now, here's the thing. They haven't told me what the diagonal is. I know the diagonals are congruent to each other, but they have not told me. All right, I want to do this for you. I'm going to fill this in, and look what I am shading in. The diagonal makes this into a triangle, and not just any old triangle, but remember, a rectangle has right angles, so this is a right triangle. When you are missing the side of a right triangle, you can do the Pythagorean theorem. 10 squared plus 24 squared equals x squared. So remember, the Pythagorean theorem is for finding a missing side of a right triangle, and the hypotenuse is always the side on its own. So a squared plus b squared equals c squared. Remember that from middle school? All right, so 10 squared is 100. 24 squared is 576. 100 plus 576, just use a calculator for all of this, is 676. And then to get x by itself, I'm taking the square root of 676, which is 26. So SQ is 26. PR is the other diagonal, and remember, diagonals are congruent, so I don't need to do that Pythagorean theorem over again. And then QT is this little section right here. I'll do it in blue. QT is this section. Remember, in a parallelogram, the diagonals bisect each other, so QT is just half of SQ, so it's going to be 13. Okay? For 2, we have a little algebra problem. Remember, in a rectangle, opposite sides are congruent, just like in any parallelogram, opposite sides are congruent. So all I'm doing is I'm setting them equal to each other and solving. So I'll bring the 3x over to the right. I'm solving for x, so I have to get rid of this 39. And again, I'm solving for x, so I will divide by 4. Now that's not my answer, because I was actually asking you to find EF. Okay, so if I want to find EF, EF is this side right here. I'm going to have to substitute in. So 7 times 11 minus 39. 7 times 11 is 77, and minus 39 is 38. Right? And then the last one down here. So let's label everything that I know. I know that DB is 42. The whole diagonal is 42. It's kind of hard to write 42, so I'm actually going to write 21 and 21. AD is 26. DAE is 52. All right, so they gave me part of an angle, DAE. They didn't give me the whole thing. Remember, these are right angles right here. So they gave me just that bottom part. So the first thing I want to find is AC. Well, AC is just another diagonal. It's equal to whatever BD is equal to, and BD equals 42. So AC is 42. EB, I already drew that into my picture. EB is 21. It's half of the diagonal, and the diagonals bisect each other. BC is right here on the right. It's going to be equal to whatever the left side is, so it's going to be 26. And AB I don't have. AB is this side right here. So what I'm going to do is, this is basically what I have. I'm just going to pull this out. AB, I don't know. BC is 26, and I know that AC is 42 because I already did that. So once again, I have a right triangle. I'm going to use the Pythagorean theorem. X squared plus 26 squared equals 42 squared. So 26 squared is 676. You're using a calculator for this. 42 squared is 1,764. So I'm going to solve for x, so I need to subtract 676. And then I just take the square root of that, and I will round it off. And I get 32.98. Another way to do this, since they didn't tell me really to round it off, I would just leave it as a radical. I'd leave it as square root of 1,088. That would be perfectly fine. And that would probably be even better to do. All right, so ADC. So let me just put this highlighter a little bit smaller. ADC is this angle right here that I'm tracing in purple. ADC is a right angle, so that equals 90 degrees. ABD, okay, is this little part right there. So I'm going to have to do a little work right here to figure out what that is. Here's the deal. Let me find this angle right here. Let me find angle BAE. All right, BAE. Remember, this is 90, so 90 minus 52 is 38. So this angle here on the top left is 38, and this, let me just shade it in for you, this is an isosceles triangle. Now, how do I know that? Because the diagonals are congruent and they also bisect each other. So this yellow triangle that I just highlighted is an isosceles triangle, and if the angle on the top left is 38, then that makes this angle on the top right also 38. BCA, I'm trying to find this angle right here. And I can do that easily the same way I did the other one, in that this is an isosceles triangle. Or, let me highlight this in green for us. This angle right here that was 52, and the angle that I'm trying to figure out, angle BCA, those are alternate interior angles, and alternate interior angles are congruent to each other. So this is 52. And DEC is this angle right here where I'm putting the big green dot. So again, this is 38. I'm looking at the yellow triangle, 38 and 38. The angles of a triangle have to add up to 180. So 180 minus 38 gives me, what does that give me? 104. So this angle right here is 104, and they were asking me to find DEC, which is right there. These two angles are vertical angles. Vertical angles are congruent to each other. So those were definitely more challenging, and we will work on some more challenging problems tomorrow. I do have a little proof here just to show you. So I want to prove this sentence: if a parallelogram is a rectangle, then the diagonals are equal in length. So what I'm going to do is, remember that if is my given, so I know that ABCD is a rectangle. That's my given. Whoops, one is given. All right, I'm going to pretend right now that I don't know that the diagonals are equal in a rectangle. I'm going to prove it by doing this proof right here. Okay, so if we're going to pretend for a minute that we don't know that. I do know that AB is congruent to CD because in a rectangle, opposite sides are congruent. So I got this side on the left, this side on the right. In a rectangle, opposite sides congruent. All right, and I do know that in a rectangle, these are right angles. All of them are right angles, okay? But angle BAD specifically and angle CDA are right angles. Okay, definition of perpendicular lines. Okay, a rectangle has, those lines are perpendicular. You could also probably just say in a rectangle, the angles are right angles. But since they're both right angles, you know they both equal 90, they have to be congruent to each other. So angle BAD is congruent to angle CDA because all right angles are congruent. What I'm going to do here is I'm actually going to prove that the overlapping triangles are congruent. It's going to be hard for me to show you which ones, but the triangle on the, let's see if I can trace this maybe. So this triangle here, okay, and let me grab another color. This triangle here are overlapping. They share side AD. So AD is congruent to AD reflexive. Now I can say that those triangles are congruent to each other. So triangle BAD, which is on the left, is congruent to triangle CDA, which is on the right, by side angle side. Okay, see what I have? I have a side, an angle, and a side. And then since the triangles are congruent to each other, that makes all of the corresponding parts congruent. So AC, which is the hypotenuse of the purple triangle, is congruent to triangle BD, which is the hypotenuse of the green triangle. Those are the corresponding parts, so CPCTC. Since the triangles are congruent, all the rest of the corresponding sides and angles have to be congruent, and I specifically wanted AC and